Brian Guzman here again, Sean Arrington.
Wait.
So tell me, what are other ways to measure mechanical properties on rocks?
So as you know, we have our load frames. We've talked extensively on that. Another common way that we can measure properties, as well as other people, are Bambino Schmidt rebound hammer type measurements, where you measure a hardness through an interval.
This is that little handheld tool that when you drop, that little thing bounces off of it and.
The Bambino, yeah, that's the Bambino.
Okay.
And so what that does, that gives you an opportunity to take a lot of measurements, so high frequency measurements through an interval for relatively zero cost or low cost. The cost is significantly lower than if you used a load frame and you did the same amount of rock mechanics plugs. You're not going to do that. So what that gives you, that gives you flexibility that you don't need the prep core. If you have a butt section or if you have a whole core, you can actually do it on that material right there. And you can do through a whole interval. And so a lot of our other labs use that data in conjunction with their primary data. For example, RGG, they do XRD measurements every 2 inches.
Geology and geochemistry.
Sorry. Yeah, they do measurements every 2 inches, geochemistry measurements. And they also do that geophysical with the Bambino every 2 inches. That way they have a physical data point or set with their geochemical data set.
Is that Bambino tool measuring or calculating an unconfined stress?
It's actually measuring a hardness.
Okay.
And then what you have to do is convert that over with a calibration to a UCS. So if you have years and years of data and you know a material, you can calibrate that pretty tight. And so that's one of the, I don't want to say downsides, but that's one of the challenges with a Bambino, that it is a calculation after that, right?
Right. So they would use like the data that you collect, which is like the gold standard, if you will.
Well,
to calibrate
that.
The
load frames actually give you a direct measurement. So I actually measure displacement strains. So you can calculate your Young's modulus and your Poisson's ratios directly. And when the rock fails, you're measuring your peak strength right there. It's a direct measurement. There's no calculations or assumptions. The problem with that is that tends to run counter for the economic side of the house. And then we also have other ways in-house that we do. We use a scratch.
Okay.
So it gives you a strength index through the interval. So that's a high frequency, moderate cost, medium confidence measurement that can give you a strength index through an entire interval of core.
Like when you say scratch test, I've seen these machines. I mean, they're literally like gouging.
It literally scratches the rock. Yes.
I would like call it a gouge. It's like deep. I mean, how deep is that cut?
Every measurement we run is 0.1 millimeter.
That's the frequency, but like when the physical engraving.
That's the deep cut. So we'll run 3 to 5 cuts.
Okay.
0.1 millimeter every cut.
Oh wow. Okay.
So it's really not gouging. It's not. You could argue it's a destructive test, but in a sense, it's not inducing fractures or damaging the core, except for where the scratch groove is. Obviously, that is. You could argue.
So is that measuring an unconfined stress directly, or you also having to calculate that?
That's a UCS equivalent. So it does measure it directly, and it does have calculations that they call it a UCS equivalent. Okay. And we've done lots of tests in house where we measure and we'll calibrate it to rock mechanics, and it trends very well.
So you'd say that's a step up from this rebound hammer. Bambino.
Yeah, and so the way I like to look at it is in terms of confidence. Bambino, it's an indirect. You're measuring hardness, you're calibrating, so I call it a lower confidence measurement. There's value there because you get a lot of measurements, and it's relatively inexpensive, and it's a data point. Then scratch, I would argue, is a step up in confidence, and then the rock mechanics would be the highest confidence. That's why generally when people do tests, they calibrate to the plugs, right? Just like when you do your log calibration.
No, I mean that makes a lot of sense. Awesome.